Okay, and I'll actually give you an extra credit project based on this insight. Okay, so let's back off. We've taken this tour, and based on this tour, we've come up with several new concepts that I've mentioned here. Okay, functional, only prefix operators, and so forth. And all these concepts came around because we looked at different programming languages. Okay? Except for the decision tree, where we looked at no language. So the question I want to ask is that, but many of these concepts occur in popular practical languages. You can have expressions return values even in Java and C. So it so happens that we saw these different concepts by taking a tour of different languages, but we were not really studying different languages. I mean, if you study in different languages, you just get into syntax. We are really studying different paradigms of programming, okay? And we are studying alternative programming paradigms, okay? If I teach you ifs and then I teach you fors, they are not alternatives. Okay, you need to use ifs in certain conditions and you need to use fors in other situations. But if I teach you recursion and I teach you for, I've got an alternative. Okay? And we can discuss the pros and cons of these alternatives. We can discuss how they're implemented and so forth. So we're really looking at programming paradigms. So this programming language, to call this a programming language course is a bit of a misnomer. It so happens that these programming paradigms were invented in the context of different languages. But ultimately, if you're going to do them in a scholarly way, we're looking at paradigms. Okay? So that's what this course is going to be about. That's why, we'll be doing this Lisp interpreter for many projects, just adding new and new concepts to this particular interpreter, which come from different languages, in fact. Okay? So if you're looking at different paradigms, let me look at something really fundamental. Okay? 110 or 401 like stuff. 110 like stuff. I don't cover this in 401. So I want to do an OR, and I typed 2 vertical bars. Okay? I could have also typed 1 vertical bar. Right? And being a bad typist, I would have preferred to type a single bar. Yet I did 2. And how many of you know that this, the difference between these two? Almost everybody. So why did I type, what's the difference between 2 vertical bars and 1 vertical bar? Again, I'm looking at 2 alternatives. Okay. Yeah, in Java or and C.
Okay, well, in Java means more. I don't know about C, but 1 vertical
No.
means typing.
So you're a Unix person,
Yeah.
and you're saying 1 vertical bar means piping.
Yeah.
So the 2 vertical bars is like the Boolean expression. So the first one value is the false value of the second one. The second one is the binary or so the value of both.
Okay. So what's your name? Chris. 2 Chris's. I got to keep you separate. So one is called the short circuit evaluation. The other is called the regular evaluation. The top one says that if the first value is true, if the left-hand side is true, I won't even bother to evaluate the second one. The second one says I'll evaluate both operands. Okay, no matter what. It's also called the bitwise OR, just because for bitwise operations you need that. Otherwise, why are you even doing this? Now, when you make a call to a regular method, not to this OR operation or an AND operation, which also has a short circuit, you pass it some arguments, right? And those arguments are passed to the body of the method. Are all arguments evaluated before the call, or are they evaluated as the call is being made? What do you expect? When you go and, supposing I had written an OR function in Java, which takes 2 arguments, and you go and give it 2 Boolean expressions. That OR function would have both of its operands evaluated before it's called or while it's being executed? Sorry? Before. Those are the semantics. If you've done a compiler course, you know that's what happens. Okay? So this short circuit OR is a very funny kind of operation. It's not something that we get when we define our own functions. Something special we did for ORs and ANDs. Something that we can't duplicate in our own user-defined methods. Okay. So doing something on demand, which is what happens with the first one, rather than when you're given that stuff, is a form of evaluation, and it's called. I know at least one of you should know what that term is, but so if I was to go and talk of the second one as being regular evaluation, what would I call the first one as? Short circuit. That short circuit makes sense for the Boolean operations. I know Robert knows the answer. Chris has already answered something, so let me give you a chance. You're more or less there. Okay. Okay. So it's often one tells the opposite of opposite of something one confuses with. So eager is the opposite of lazy. Okay. And the word lazy seems right? That you're saying, I tell you go and do all these things, and you say, well, when you really need something, I'll do it. I'm not going to do it right now. Okay. So that's lazy evaluation on demand. So normal evaluate all operands in sequence before operation is executed. Lazy evaluation is evaluate the operands when they're needed, and if they're never needed, don't ever evaluate. Okay. So what might eager evaluation be? Nathan? So greedy algorithms are in machine learning. You just sort of that's a very different thing. So in one case, I'm doing them in order, left to right. That's my regular evaluation. Lazy is who knows in what order, when they are used, I go and evaluate them. Chris, you got an answer? No. Okay. So what's the opposite of lazy? What would eager be? What is even more eager than doing in order, left to right? What could eager mean? Sorry? In whichever order, but that's just scheduling. It's still not doing more work than you need to, or being very eager. I give you assignment 1, 2, and 3, and 4 at the same time. Yes. Okay. You do it in parallel. Okay. So good. So, and that eager OR will basically concurrently ignoring side effects. Now, when you start doing eager evaluation, or whenever you start doing lazy evaluation, you're sort of breaking some rules. Left to right evaluation means that you're guaranteed that if the left any side effects of the left operand are seen by the right operand. Right? We know that expressions can have side effects. They can change global variables, for instance. So evaluating them left to right, then we are guaranteed a certain semantics. If I start evaluating them in any order, in the order in which they're accessed, suddenly that guarantee goes away. If I evaluate them concurrently, that guarantee goes away. Okay? So when you do lazy or eager evaluation, you're hoping that there are no side effects. In a pure functional language, there are no side effects. So lazy and eager evaluation are terms used more in the context of functional languages than non-functional languages. Even though functional languages that we are seeing in practice have side effects, a pure functional language will not have side effects. Okay? So that's what. So that's lazy and eager evaluation. Okay, and lazy and eager evaluation, eager evaluation is going to be the reason why we do concurrency. Okay, or will be the driving problem for concurrency in our class. Okay, so concurrency can be motivated by many factors. But we're going to motivate concurrency by saying that programming language implementation requires concurrency. We're into programming languages, design and implementation are very related to each other. So we'll go and look at how concurrency can help us create different kinds of interpreters that are more eager than the regular interpreters. Okay? Okay, my animations were in the wrong order here. So the last thing I want to ask you guys is, so concurrency. Now in my 401 I teach concurrency. Those of you, at least one of you took distributed computing, you've seen concurrency. How many of you have not seen concurrency at all? Feel free to say so. One person is admitting to it. Okay, so those of you who have taken KMP's 401, where have you seen concurrency?
KMP taught it.
He taught it?
Yeah, it's like the last thing you do. He taught it.
Okay, good. I've been telling him for a long time to do concurrency. I didn't know he did it finally.
Well, when I took it, he did it.
Did he do it after? He's doing it? Great. Did he do synchronization also?
Yeah.
Okay, good. So you guys have seen, yeah, Nate?
I didn't do it, but when I was learning Go, we learned I don't think they were called threads, Go routines. Go routines is how I learned about concurrency.
Okay. So coroutines is, again, the concept is 60s, 70s in this latest language called Go. So, okay, my animations are all off here. So even if you've never seen concurrency, as a user, you've seen concurrency. And what is the concurrency we are seeing here? For those of you, this is from the Windows screen down. What is the unit of concurrency here? Processes. Okay. And what's another term for concurrency that some of you mentioned? Parallel, but process is one abstraction for concurrency. There's another abstraction that's different but related. Yeah. Threads. And what's the difference between threads and processes? Sorry. A thread is within a process. Okay. So as a user, you see this concurrency. As a user of a debugger, you also see concurrency, which is the thread concurrency. So if you ever put a breakpoint, you'll see that the debugger will show you all the threads that Java creates automatically, plus your thread. Okay, so the Java program you're running has many threads. Your main method runs in one particular thread. In this particular example, the program has created 2 threads. But when you're stuck, when you put a breakpoint, it's on a particular thread. Let it execute it, okay? So, in fact, if you use Eclipse or any other programming environment, you've seen concurrency at that level too. Okay? So, process versus thread. So, you take a program, you execute it, you get a process. Okay? And the process has got some code. Okay? It's got also static variables. That's what belongs to a process. Okay? Same program can result in multiple processes, so I can have 2 Eclipse instances running, 2 Word instances running. That's a process. Okay? And processes are independent activities. If you've got multiple cores, they can execute concurrently. Otherwise, they can interleave one after the other. Thread is also an independent activity, but it occurs within a process. What does that mean? It has access to the code of the process. It has access to the static data of the process. And each thread has its own stack. Okay? So in the stack, those methods are pushed and popped sequentially. So the code within the stack is executed sequentially. But when you want something done concurrently, you go to 2 different threads, each with the independent threads, independent stacks, independent program counters as a result, independent pushing and popping of stacks, stack frames. So that's what a thread is. Okay? We're going to look at this in more depth later, but now that I know that you guys have actually seen this stuff, I can go a little faster when we talk about concurrency later. Okay. How many of you feel comfortable with concurrency? A few people? With synchronization also? Okay, good. So then you're the guys I'm going to point to next to solve our problem. Okay? So I want to go and do this operation eagerly. Okay, so I've got two Boolean operations that I need to be done. I don't want lazy. I don't want normal evaluation. I want eager evaluation. Okay, remember this is occurring within a particular application. The users entering many pairs of final scores and total scores. Okay, so that's the program we have. And there's this one method here that I want run concurrently. Now the first question is, how many threads do I need for this program? You can have large number or small number. I would like as small as possible. So the users entering total score, users entering final score, and the user enters many such pairs. And each pair I want the two left-hand side and right-hand side to be evaluated concurrently and not sequentially. All you guys feeling Astra? Two threads for all the lines, or for each line? So I enter first the score 50, 49, then I enter 70, 89. Do I use 4 threads or 2 threads? Okay, good. Okay, so we're going to use 2 threads here. If you're going to use 2 threads, life becomes more complicated. Do we need? People agree with that? That's the minimum I need, right? Hopefully, that can also be the maximum if I do this problem right. So I'm going to only have 2 threads. Do I need any synchronization between these 2 threads? Because I have 2 threads processing multiple lines. What are these threads doing? I mean, how do they go and figure out which line to process? So the controller goes and gets a new total score, gets a new final score. The controller blocks, trying to get that, right? Whenever you do a read, you block. Okay? So there's going to be, how many threads will I create? I need 2 threads. How many threads will I create dynamically? So if I don't create threads at all, how many threads are there in a program, in a process? And that thread executes the main method. So far, we had 1 thread in our program that executed the controller code, that executed the model code, that executed the view code. Okay? And whenever the controller thread went and did a read, it blocked, waiting for the next input line and then the next input line for this one. Okay? So there was some synchronization going on there. It didn't just, because it knew once the values were set, then it went and computed on those values. Remember that we have variables. We have 1 variable for the total score in the model. We have 1 variable for the final score in the model. Okay, so we have to kind of figure out how these 2 threads are going to process multiple values of these variables. Okay, we know that the master thread or the main thread blocks. Okay, does the other thread also need to block? If it's not blocking, what is it doing? Sure. So we know we have a variable called final score, total score. Okay. Those are 2 variables in our model.
Okay. I was saying, like, if they were like changing something, like I don't think they would be changing their inputs, but if they were changing some like static variable, if both of them were, then they'd have to be.
No, but do you remember how we coded our application? That we went and the controller went and changed the model's total score and final score. So there's only one slot holding the current value. Okay, each time the controller got a new value, it went and called a set scores method in the model. The set scores method went and changed those variables. Okay, so we know that our main thread does wait for new values to be put there. Our slave thread, Nathan?
We really don't have so much context on this because the way that I would have implemented it is just putting in, you have a function, input total score, and final score.
Yeah, so exactly what I do.
I don't understand why would they be waiting on something? They've already been given that in this scenario.
Who's the they? The main has been given something.
The main gave its own function these own answers, right?
The main got the total score and final score.
Is this not a function of the main?
The function main got its. I'm telling you, the main weighted.
Yeah.
The slave is going to compute. So the main will compute now the regular pass. Okay. The slave is going to compute the high final pass. The main waits for the new values of input, right?
Why is the main doing regular pass, but the slave is doing my final pass?
It doesn't matter. One of them has to do one of the other pass. Okay. So the main is doing the left hand side. The slave is doing the right hand side. The main waits through the read method. The slave must also have to wait, right? By definition, otherwise it may not. It's going to access some variables in memory. If those variables have no values, what's it going to do? Okay, and if you guys do web programming, what do? You go through a loop, and you go and say sleep for 5 seconds. This is what I've seen from all web programmers. I don't know where you guys get this from. And then you go and check the values of the variables again, and then go and sleep for 1 second. And I have so many students who've written code like this, and I say, oh, why? Just busy waiting. Okay. So what you need to do is you do need for the values on which you operate to be set. And when they will be set is determined by the user. So you do need the slave to wait for new values. Our master is already waiting through the read line methods. Okay? We similarly need the slave to wait through the wait method. So just as understanding how object-oriented programming works is not hard, figuring out how concurrency should be used is even harder. Okay? And that's why I kind of smile when I said, how many of you know how to use the synchronization facilities? Okay? So let's take it then that the slave has to wait for new values. Does the master have to, so the new values come from the master. The master's controller gets the input, and the master's controller then goes and tells the slave, hey, there are some new values to be computed on. Does the master have to wait for the slave?
Yeah. Before you can get more values from the user, it needs to finish processing its other one, right? In this scenario.
Okay. So,
Like
somebody else? I'll give you a chance to figure, but just raise your hand before you answer, because I want to give other people a chance to. So what does the master wait? If the master has to wait, what does it wait for?
Waits for the return of high final.
It has to wait for the slave to finish computing its value. Okay? So there's both kinds of waits. Okay? So that's how the problem, yeah, Robert?
But it only waits if regular pass fails.
So, I did it two ways. I first put a short circuit OR there, and then I couldn't show you what should happen, so then I put a non-short circuit OR there. Because we're doing eager, right? So I wasn't getting the printout I wanted, so this morning I was changing it to because I just instinctively put short circuit. Okay, and my code will work with that too. So, how many threads for eager evaluation? And the coordination between master and slave thread. Okay, so here's a script that tells you what's happening. Okay, firstly, there are two threads here. This is the thread that was created automatically for us by Java. Okay, and there's a thread we created. Now we need to know, if we are doing concurrency, we need to have an abstraction to create our own thread. Okay, that's one thing we need to know from a programming language point of view. So we see in the top that thread 05 main, so this is the master. And this is the thread that was created by the master or main thread. And its ID is 05 main, and one guy's ID is main 5 main. Okay? What these IDs mean, is not that interesting. So this is a slave. Okay? The slave starts off and it says, I'm waiting for new scores. Okay? It's running a loop of some kind, and it says, I'm waiting for a new score, and it blocks. Waiting means block. Blocking, you've seen when you do reads, you block for the user input. Here you're blocking for something that has to occur internally within the program. Okay? Somebody should go and unblock you later, and that somebody will be the master. Okay? So now, that thread got started and it started waiting. Then the user took their time to enter input. As soon as the input was entered, the master said, hey slave, unblock. Okay? So we need some way, we need some construct to block, we need some construct to unblock, and we need some construct to create a thread. These are the three constructs we need from a programming language point of view. Okay? So, and the thread, slave waits for two conditions. It waits for new scores. Also, it waits for its computation to have been consumed by the master. It'll go and write its result into a variable. It doesn't want to go and write to that variable another time until that master has read that value. Okay? So there are two ways the slave does. You can do this problem in many ways, by the way. I didn't introduce any new variables. I just used the existing variables I had. So it waits for new scores and for its input, for its output actually, I shouldn't say input, for its output, for its computed value to be consumed. So we have two waits. Okay? The exact algorithm doesn't matter so much. I'm trying to emphasize more the fact that we need a way to wait, we need a way to unblock, and we need a way to create a thread. Okay? Similarly, the master needs to wait for the value to be produced by the slave. Okay? And then we see a lot of unblocking pairs, which is just this unblocking construct. Okay? You get the basic idea? Okay. Again, the exact algorithm can vary, and we'll look at this in depth. But I want to just indicate that we need three kinds of constructs. Okay. Questions on this? Okay, this is an example of unblocking pair. We see a lot of unblocking going on here. Okay. So, how do we create a thread? You guys see some code here that's creating a thread? Is there anything strange here that you haven't seen before in Java? That's just a name I gave, right? That's just a name. I can give a class any name I want to. But that's hinting at what's inside the class. Do you see a lambda expression here?
Is that what those parentheses are? The new thread on the line 4?
So let's look at that line, new thread. That's the funny part, right? Everything else is just regular Java code. There's nothing strange there. So I must need a way to create new threads. Okay? As a programmer, you can't create threads directly. You need the OS's help. Okay? So we need an abstraction from the operating system or from the Java runtime to create a thread. There's a class called thread that gives you the abstraction. In Java, things get instantiated. Okay? So we instantiate the thread, the class, and we are saying, create a thread and start it. Okay? Now, we don't just say new thread dot start. I'm giving to the thread constructor some argument. Logically speaking, what should I give to what do I need to tell the operating system to create a thread? Forget what the syntax is, whether you use pthreads or something else. What do I need to tell some operating system when I want to create a new thread based on the definition of thread? What's your name? Ben? I got to keep you guys separate. So, every thread is its own stack, right? I want to give it the base of the stack. When you go and declare something as public static void main, you're telling Java's runtime, this is the start of the stack. Okay? Based on the signature I've got. You just say, explain it statically. You never go and do that. But now you need to go and give it the base. So I need to give it basically a procedure address, right? And my lambda expression is a block of code that's parameterized, and that is essentially a procedure. And this thing says, that this is lambda expression, and that procedure that I'm going to call takes no arguments. That's why there is two parentheses. If that procedure took more than one argument, I would have within the parentheses the arguments n1, n2, n3, so forth. This takes no arguments, and the block of code it runs is the method called run. So I'm telling it, whenever this block of code is called, go and call the run method, and run method is provided below. So I'm giving it a lambda expression that takes no argument and that calls the run method. That's what it's saying. And the run method is given there, and as I promised you, it's a loop that keeps going on, and it's got this method that I'm saying wait for new scores. Hopefully, we don't know what Java construct it is using, but it is somehow waiting for new scores, and it computes the high final pass, and it prints it out too, unblocks anybody waiting for that value, and then it waits for null scores. Yeah.
Why exactly do you need to have the unnamed function saying do this run function? Why can't you just say run? Like thread, call this function run?
Okay. This is a good question. This is an excellent question. Why can't I just say new thread, and within parentheses I give the address of a run method? Have you used C? In C I can do that. In Java I can't do that. In C I can say give the address of a method, and you can do that. If I do it in C, is there any restriction on what kind of method I will pass it? I can pass it a push method or a pop method. They have different signatures. So the caller can call the method in ways that are inconsistent with the method that's called. There's no, if the caller is expecting a push and you pass it a pop, we're going to run into trouble, right? So that is why Java said we don't want to deal with method, with just passing addresses. But I'm now passing a lambda expression. Lambda expression has arguments there. Hopefully the lambda expression is going to be consistent with what the constructor is expecting. So that's why I'm passing that. For those of you who've done threads in KMP's class or my class, we didn't use lambda expressions. What did you guys pass instead?
Classes.
An instance of a class. An instance of a class that had what constraints on it?
Extend the thread.
Oh God, is that what he taught you in class? Extend thread? I actually, so as you know, we guys evaluate each other for teaching. So I actually evaluated him in one of his web classes where he did that. And I said, hey, you're doing it wrong. And he corrected it the next time for the evaluation, and he's gone back to his old ways. Okay? So that is just a horrible way of doing things. Okay?
That was like 4 years ago, so I don't know if he still does that.
Okay. I did that evaluation much before that. So, but maybe you got this from somebody else. No, what's the alternative to that? What's a good way of doing it? Implements runnable. Use interfaces. Okay? So this is essentially saying this lambda expression is really a runnable method. Okay? That's what it's really saying underneath. Okay? How far I've got? How many seconds do I have left? Okay. So this is my lambda expression. Okay? And lambda expression is executed as the base of new stack. That is the basic point here. That the thread conceptually is starting a new stack. We somehow have to, in a safe way, give the thread creator a pointer to the method. Okay? And safe way means that we shouldn't be able to pass it the wrong kind of method and run into some runtime errors. And we will start from here next time. Okay, so review of what we did last time. We looked at, for those of you who hadn't seen this concept before, the notion of a classifier that is data driven. And we saw that there was sort of like a compile time phase when you train the classifier and it comes up with an algorithm. So it's like a very heavy runtime that it generates. And then at runtime, you'll give it test data and it gives predictions. Okay? And we saw that through a diagram and we saw that through real code. And what we did here was we created in our Smalltalk MVC architecture a new kind of model, a Smalltalk model, that didn't have any logic in it to compute grades. And it had a constructor which was, so this was all running at runtime as far as the Java program is concerned, but it had a constructor that actually first created the model, the Vecca model, and then during interaction time, after the object had been initialized, it went and actually asked for classifications. Okay, so every time the superclass said, hey, tell me whether these scores are passable or not, the isPass method was called, and it went and made predictions based on the created model. Okay. And since we didn't really hardwire the logic, we have to trust the data and the decision tree model to its job. So we actually even saw whether we were getting correct results or not, and I told you that everything I tested on it was true. Okay, but in general, we are not guaranteed. So we were trying to figure out, why would you ever bother to do things where you're guessing rather than being guaranteed? Assuming, of course, you might have to program less, but what if we're willing to program? So there were two reasons. One was that getting the correct answer might be impossible or might take more time than we're willing to tolerate. And so we might want to use guesses or inferences as alternatives. And then there's other reasons where we really don't know how to get the correct thing. Okay, we don't understand the world well enough to get the absolutely correct thing. Okay, and we saw many examples of that have to do with human psychology, but also human physiology. We don't really understand how things work in the human body. And for all these inference algorithms, you need some ground truth. What is correct? And in our department here is actually world experts in image processing, and I've talked to them, and they say, we don't have gold standard ground truth. We have bronze standard. Okay, so even the doctors are making guesses, and so we can, so maybe the program can make as good or better guesses. Okay, or maybe the human guesses and the program guesses can be combined together, which is the more practical approach. Okay. So from there, we were going to motivate concurrency, and you can motivate concurrency through many ways. And I used parameter evaluation as a way to do so. So we have short circuit, which is lazy evaluation. We have regular computation, which is normal evaluation of parameters. And an eager evaluation, we don't go and evaluate parameters left to right or lazily when they are used, but we evaluate them in parallel. Okay? That raises lots of semantic issues, but it also raises some concurrency issues. How do we do things in parallel? And most of you had seen concurrency at the program level, but almost all of you have seen concurrency at the user level. If you looked at the list of processes in your computer, processes execute concurrently. If you've been in a debugger and never put a breakpoint, you'll see that there are many threads in your programs, one of which may be created by you, but the remaining created by the JVM. So there is these threads and processes are both units of concurrency. Processes run on different programs. Threads run within a process. So all threads within a process share its code and its global static variables and its heap. Okay, and what they have that's private is their stack. So each thread is a separate stack, and that can work independently. Okay. So how do we create thread? We have to somehow create. So when you create threads, that's not hard. The challenge is how to synchronize them. Okay. And in our problem, which is quite simple, the first question I asked you was, how do we? So we want to parallelize this. We want to go and evaluate regular pass and high final pass in parallel. Okay. And we want an eager OR operation to do so. So this eager OR is not a keyword in Java, but I'm just putting that as a keyword. Supposing we did, we'd like the regular pass and high final pass to be done in parallel rather than done sequentially. Okay. So the question, and we want to do this repeatedly, right? For every pair of scores that the user inputs, we want it done. So I asked you guys, how many threads do we need in this program? And a simple answer is that for every pair of input, we need a pair of threads. Okay, and you can do it that way. That will be probably simpler, but that will be wasteful because each thread starts its own stack. Okay, so even a procedure call is more expensive than just going to the next statement because you have to push a frame onto an existing stack. With threads, you have to create a new stack, and you have to go and get involved with the operating system. So thread creation is expensive. So we, intuitively, students said that, look, we just need 2 threads because we have a pair of values. And our master is a looping master. It goes and, in a loop, goes and reads pairs of values. And master is the main process, a main thread. And we can create another slave thread that does, so the master can do the regular pass, and the slave thread can always do the high final pass. Okay? So the master is looping, so should the slave. It should also be looping. And they can't loop independently. Okay? They have a producer-consumer relationship between them whenever the master gets a new pair of values from the input. So the controller, model, and view run in the master thread. Okay? So whenever the controller gets a pair of new values, it should go and tell the slave thread, hey, go compute the high final pass. Okay? So the slave should wait for those values to be produced. And similarly, the master is the one that will combine the 2 results. So it should wait for the slave to produce its high final pass value before proceeding. Okay, so they both have a producer-consumer relationship among them. Okay, questions so far? So from a language design point of view, we have 3 questions. How do we create a thread? How do we make a thread wait? Okay, so when it's a consumer, it must wait. And how do we make a thread unblock a waiting thread? Okay, and I answered the first question last time, and that was our chance to go and show Lambda expressions in Java. So this part here, we are creating a new object called thread. We all know how to do new. Once an object is created, we know how to invoke a method in it. We are invoking the method start in it. Okay, that's saying create a new thread and start it. That seems intuitive. What's funny is what we are passing as a parameter to thread. Okay, and what we are passing as a parameter to thread is a Lambda expression. Okay, a thread begins a new stack. We should know where to start executing. So we need an address of some block of code. In general, the block of code may be parameterized, and that's exactly what a Lambda expression is, a parameterized block. Okay, you can do it other ways, but this is consistent with what we did in Lisp. So we throw a Lambda expression that says, I'm running a block of code that takes no parameter, and that block of code can do anything. It can go and say system.out.println hello world. Okay, but what we're doing is we're not putting the whole code in line there. We are actually calling a method called run that we've defined in the program. So the run method will be called, and we see here that there's a loop. Okay, so this is where we get our slave loop, that it's continuing on processing multiple values. Okay, we also see that this loop computes the high final pass in a variable. Okay. So what we've done here is we created another model in the MVC structure that we created. So this is the concurrent model, and it uses Lambda expressions. So I say a Lambda concurrent pass model. I also have in my published repository a non-Lambda implementation. And it goes and waits for new scores. That's what we need to do. It unblocks it computes the high final pass. It unblocks the master waiting for the high final pass. Then it waits for null scores to wait for the scores to get null, and then it waits for new values to come. Okay, so that seems intuitive, but the question the question is, how do we implement these parts? So those of you who've implemented Java threads in Java, what do you use in Java to wait and unblock threads? You can join on a thread. What does join do? So it waits for a thread to, intuitively when you join a thread, you're going to wait for it to, you fork a thread and you can join a thread, and join would do what? Exactly, yeah, it waits, but waits for what condition? To end. It waits for the thread to end. We are not, so that's what we would do if we were to create a pair of threads for each user input. So join actually is implemented using some lower level primitives. So you don't want to wait for the end because the thread's not ending. Andrew? Sorry, Ben. We can sleep. And is there an awaken in Java? So when you do sleep, you say sleep with a timeout. And you say, but you're getting the right idea. We want to block. And you say sleep with some timeout, and then it will sleep till that time. Okay? And you can always interrupt a sleeping thread, but that's not a good thing to do. Okay, but we need something as sleep, and nobody's actually used that primitive. So you need a sleep, you need a primitive just like sleep. You need something to awaken, unblock, and need something to wait that is not based on time. Okay? Yeah.
Does Java have async await?
Java has what?
Does Java have async await? Asynchronous and like await when it awaits a function, or is that just JavaScript?
So I don't know much about JavaScript. Okay, but Java, in fact, in JavaScript, I believe you have no threads. Okay, so that's one of the problems we are facing when we're writing some web apps. So, but yeah, you need those two operations. What they're called is sort of not very important. But every object has a method called wait on that you can invoke on it. Every object. Okay, and the awaken method is notify. Okay, so a sleep that does not wait for time, but just waits to be awoken by another. So I'm just using Ben's vocabulary here. This is a sleep that is not depending on time, but on some other thread to awaken it. Okay, so there's notify and there is wait. Okay, so that may be new to you. Yeah.
In that example, when it waits, anywhere calls notify. When anywhere in the code calls notify, does it make the wait stop? So does it? So you can't like target the notify a specific thread.
Okay. So can you notify a specific thread? So I can't tell you how many concurrency languages I've seen in my lifetime, and there are languages where you actually do that. Okay, and there's been a whole history of synchronization primitives, but Java just says that anybody waiting. So every object,
So it just calls everything.
anybody waiting on that object is notified. But when you wait, you can check for what condition you're waiting. Okay? And before you call notify, you can set a condition saying, hey, I really want to notify this particular thread. So you can change a global variable saying, I'm really interested in waking up thread number 10. So when a thread gets woken up, you can say, am I thread number 10? If not, I'll go back to waiting. Otherwise, I'll do my job. So you can simulate what you're talking about this way. And hardwiring things to a particular thread is probably not a good idea because who knows, it's too much coupling between threads. So hardwiring it to some condition is a better idea. So notice that we did not just do wait without checking anything. We actually went and checked a condition for waiting. And as long as you can check conditions, you can do anything. Okay? So wait and notify are new things you've seen here. Any other new concept you see here? Any new thing that you haven't seen before in Java that I've written here? Synchronized. And that's a keyword. Wait and notify are just predefined methods defined in class object. Okay, so if you ever go and say this dot, you'll see toString, you'll see a bunch of methods, you'll see clone, and you will see wait and notify. So you can wait and notify on any object. Okay? So somebody want to guess or somebody know what the keyword synchronize means here?
It's like a monitor, right, where only one thread can access that function at a time.
So you've done operating systems or okay. So if you've done operating systems, then this is old hat to you. So Ben used the word monitor. So any module, we said a class that is really a module that's instantiatable. And when a class has a synchronized method in it, then the class becomes, or when a module has a synchronized method in it, it becomes a monad. Okay? And synchronized just means that the method execution is serialized. Okay? So only one thread can execute this method at any one time. It means more than that. It means only one method in this class. No other synchronized methods can be executed in this class. Actually, it means that, or this method. So why do we do that, by the way, or why are we doing it in this example? Why are we making sure that two threads don't execute these methods concurrently, that their execution is serialized? I mean, threads is all about increasing parallelism, and now we're reducing parallelism.
So you don't get deadlock.
Actually, when you wait, the chances of deadlocks increase. If you were not to wait, you tend to not have deadlocks. Because deadlock means that we are waiting for each other. If we never waited, we won't have deadlocks. But deadlock is a term that we use in conjunction with another term, and the race condition is the other. There are three terms: deadlock, starvation, and race condition. Race condition is that things are not consistent. Okay, statements are not executed atomically. They take underneath. They take multiple instructions. And if you're in the middle of the instruction sequence, then you might leave data in an inconsistent state. Okay, and we'll look at that in more depth when we study in concurrency in more depth. But whenever there is shared data structures, whenever there are two threads that to access the same variable, you should, especially if they are writing, you should serialize the execution. Okay, and in wait for new scores, is there some shared variable that we are accessing? Is there some global variable we're accessing? Any global variable is shareable. You don't see it directly, but what is the condition for waiting? So we are checking, the getter is checking some variable value, which is going to be set by some other thread, right? So that thread should change the variable in a synchronized method, and this thread should go and read the variable in a synchronized method. Okay? Actually, we don't need both of those in general, because if the writer is doing it in a synchronized method, that will be fine. Yeah, go ahead.
So is that the way that you were talking about notifying the specific thing? Is that how you implement it? It says if and then try and then it, I don't know if I'm just familiar with the syntax, but how does it go from waiting to looking back at the if statement when it is already
That's a good point. So right now I'm saying if not okay to proceed, then wait, right? There's only two threads here, that's fine. In general, I will say while not okay to proceed, wait. That's how we will do your problem.
Yeah, that's all.
Yeah. Okay. So the synchronized keyword argument here is a little weak because there's only one writing thread, and like I said, as long as the writing thread is executing it atomically, the reading thread is guaranteed a consistent value. As long as the read is atomic, because in the middle of the read the writer can start, which could cause problems. So I think in general, if you assume that the read is not atomic, we would need both reasons. Why is the unblock peer in a synchronized method? We can argue that the wait for new scores should be in a synchronized method because we're accessing a global variable. The unblock peer is just notifying. So as long as notify does not access a shared data structure, we are fine. You know, if there's more than one thread notifying, fine. There's nothing wrong with that. Robert? So you might have interleaving of notify and wait. Do notify and wait access a shared data structure? As long as if they access a shared data structure, we need to not interleave them. But is there a shared data structure? The object lock. Yes, and also there's a queue. So you can think of that as object lock would be binary, but actually you have a queue of waiting threads. So that queue has to be accessed atomically also. Okay, because ultimately if a thread waits and it can't proceed, it's put in a queue, and multiple threads can also wait. Okay, so that queue represents a lock we are talking about. So we need to put that also in synchronized method. Okay, so if you ever use wait and notify, they better occur in synchronized methods, otherwise Java will complain. Okay. Questions?
Synchronize does the following: it serializes and makes it so that it can be the only synchronized method within a class.
Yes, so only one synchronized method can execute in a class at one time.
Execute class at one time.
Sorry?
More than one can exist. Only one that can be executed at one time.
More than one can exist. More than one can be waiting in a queue. So there's a synchronized queue and there's a wait queue. There are two queues in each object. So objects are heavyweight. Okay, and this is important from language design point of view. Why did Java have primitive values and objects, both? You know, in Smalltalk, that was not the case. And there's many reasons, and one of the reasons is objects are heavyweight. If you made every int have two queues with it, our ints would become very expensive. Okay, so there's all kinds of data structures associated with objects. Okay, so synchronized methods execute serially by threads, and wait and notify, block or enqueue. So wait notifies and wait blocks and enqueues the thread, and notify dequeues and unblocks a waiting thread. Okay, we'll get to the this gives you the basic semantics. We'll get into sort of the more detailed semantics later, but this can get you started if you're actually writing a concurrent program right now. Okay. And why synchronized method? Total and final score are shared data structures, so wait should be synchronized, as should set score. Set scores changes these variables, so it should also become synchronized. So I told you that, threaded programs are hard to get correct. And part of the reason they're hard to get correct is because you have to put these, you have to synchronize, you have to make sure that the synchronization occurs correctly, and it doesn't lead to deadlocks where you wait on each other. Yeah.
So I'm confused because if you want to call these two functions, they are not static, right? You need to instantiate an object. So why can two threads can call this function? Are they sharing the same object?
Yes, they're sharing the same object.
So this object must be in a stack of the belongs to this process, right?
So objects are in the heap. Okay, they can be accessed by any thread in the process. If I create if in one procedure I create an object, that object is not created on the stack. It's created in the heap. After the procedure goes away, the object remains as long as somebody has a reference to it.
If these objects are in the stack of a single thread, there's no such problem, right?
If objects were created on the stacks, there would be no such problem. But objects are not created on stacks in Java. They're always done in the heap. In C++, you can create data structures on the stack, okay, that are non-primitive values, okay. But in Java, it's like doing a malloc. If you know C, you've created something from on the stack, on the heap, and it's global. So this also means that when you call a method and you return back, some other method can look at the objects waited by the first method. That's what happens with the construct. Okay. So wait and notify and synchronize methods as they access queues of block threads. Okay, questions? Okay, now how does the logic quite work for the application? That's a detail that we don't have to go to, but if you want to, sort of really understand what's going on, you can look at that. So, concurrency is an important concept. It's so important. There's a whole movement, I might have mentioned this in the beginning, that every class should teach concurrency. Okay, when you go and first teach in Comp 110 like course how to go and do a sum of n numbers in a loop, you should also teach them how to do the sum of n numbers concurrently. Okay, when you teach sorting in data structures, you teach it parallel sorting. And so, you know, we guys haven't quite embraced that idea as yet. So we're going to do some concurrency here, but you will, if you take a graduate course, there is another course, 633, that will do concurrency from a high performance point of view. You look at concurrent algorithms, and you know, just to make sure that you get important concepts before you graduate, I'm going to do the basic concurrency construct, which I've already done here. Okay, we'll look at them from an implementation-oriented point of view later, and we're going to use it to use this to do eager evaluation in programming language implementations. Okay, so that's the tie to programming languages. I'm putting it. Okay. Okay, so when you talk of concurrency, you often talk of high-performance computing, and another way to get high-performance computing is to have a distributed program. Okay, and we're still again we're taking a tour, so we're not really doing things in great depth, but I just want to give you a basic feel for this area. And let's just try to define a distributed program. And we can argue that a distributed program involves communication among multiple computers, right? That seems like a nice intuitive definition. I'm going to argue that a program can be distributed even if it doesn't execute on multiple computers. And anybody want to sort of provide an argument for my provide justification for my argument that I can claim a program is distributed even if I don't run it on multiple computers? Hutch?
Maybe something like on the graphics card, like or an external graphics card, but it's not on the CPU. It has to like outsource to that.
So but if you're running on a particular computer, so are you going to run that as multiple threads, or are you going to run that as multiple processes? So whenever you have the ability to share memory, as you do on a particular computer, you tend to create threads which are more lightweight than processes. Okay, but that's where, but so you're getting to it. Anybody else want to expand on that?
To add for what you said, particularly like for graphics cards, some tasks are better done on like multiple cores instead of like on a really fast single core processor.
Okay, so when you have multiple threads in a program, they're not confined to one core. Usually the different threads, one of the reasons you have multiple threads is to execute them concurrently in different cores. So you are getting real parallelism. It's not threads does not imply interleaving. Threads hopefully will give you real concurrency.
But even still, like even if you have them being done, even like a super fast like CPU, it might be better done on like a graphics card that's doing the process really slowly. The fact that it's on a graphics card that can do it slower, the fact that you have like a lot of cores doing it, it would still be better to do it on the graphics card.
Yeah, so I'm saying the graphics card can also access the main memory, right?
Just access the graphics card memory and it can execute the tasks from the.
Yeah, so all devices can access the regular memory. They communicate through the bus, but they have access to the memory. So when we talk about distributed programs, what really do we mean? And let's sort of say, let's go with this definition, and this will be a little clearer. Okay. When we say that a program is distributed and it runs on multiple computers, it's not that it runs on multiple computers, it can run on multiple computers. Okay? And the specific computers are not bound when the program is written. Okay? You might execute them, because the program is not dependent on a specific set of computers. So if they're going to be bound at runtime, that means they should be able to run on a single computer too. Okay? It's not as if a program has to run on 5 computers. and these 5 specific computers. It could run on 3 computers also, and with one computer executing two parts, serving the purpose of 2 computers. So it's really a program that involves multiple processes. And processes have, the difference between process and thread is that processes don't share memory. Okay? So on a single computer, you can share memory, and if you're really doing high performance, you should share memory in threads, but you needn't share memory. And so you could go and run them all on one computer. Why would you do that? We'll, who knows? But from a definitional point of view, it's really a program involving multiple processes. These processes can run on one computer or run on multiple computers. Okay? And these processes can all share a single core, or they can have multiple cores. And usually sharing through threads is faster than sharing through processes. So we will really do a threaded application.